Hey, good morning, everyone. Good morning. Anyone there?
Good morning, Professor.
Morning.
Hey, good morning. How's everybody?
Morning. Morning.
Good morning. Looks like I see four people here, and let's see how many are in the forum. Yeah, four people. So whatever number of people I have in the forum, I have in the collaborate. Uh, Good. It's 100% 100% participation, right? Hopefully, more people will join us shortly. Um, so, a couple of things I would like to mention, right? A couple of things. Tion, if you are not, if you haven't signed into the forum, please do it ASAP. A couple of things. Everyone knows that the midterm will be the announcement has been posted, right? It was emailed out to you as well. Uh, yeah, midterm instruction was. Oh, it's not yet. Okay, but it's gonna be there. Friday. Tomorrow is Friday, so it's gonna go out tomorrow. It will be posted here. Uh, Another thing. Um, you need Connect access, right? Because absolutely from all your exams from midterm and forward will be on Connect. So you need the Connect access. Okay. Please, make sure you activate your Connect access. Okay, if you haven't done yet. Um, Quiz one summary statistics is posted in the assignments folder. Okay. All righty. So with that, uh, so let's p- let's pick it up from where we left off, right? Okay. So on so on Tuesday, basically we talked about uh, what compounding is, and we know already, because this is something we've done in topic one. But this is the base formula, right? Uh, Compounding, right? Through compounding, finding future value, that's the base formula, right? But if principal is the unknown, right, we can solve for principal, right? Um, which is the reverse process of compounding, right? And this process is called discounting. I told you this is the reverse process, right? Discounting. So they are reverse process, right? Reverse processes of each other. Now, and because we have four variables, I've been telling you, we have four variables in the equation. That means we can uh, answer four questions about it, right? The first question was, of course, what's going to be the future value? Second question was going to be the principal. What should the principal must be? Third question is, then what should be the R? What should be the interest rate? Right? So then, uh, other than the unknowns, right? All the others are known quantities, so they are known variables, and to solve for that, and I told you we did this in topic one because at the time uh, we wanted to find the geometric average, right? And the geometric average in under scenario one. on the scenario 1, right? That's, okay, okay. I don't know if you can hear this, noise, but it's a white noise. It's not exactly a white noise, but somebody's, always there. There's always someone doing some home improvement in this building, in my building, and it may not be bothering you, but it's like pounding my head. It's bothering me.
Yeah, we can hear it as well.
Oh, you can hear it too.
Yeah.
Somebody's drilling, on the wall, or it's a good thing it's not a jackhammer. If it is a jackhammer, it's really I'm gonna probably blow up. uh, but so in scenario 1, I told you that uh, return is exactly growth rate in scenario 1. But in scenario 2, return and growth rates are different because there's additional cash flow. But in scenario 1, they are the same thing. So we found this, right? Uh, exactly in the same way, and that was called, geometric average. Geometric average, right? And also sometimes called, CAGR, uh, which means compounded annual growth rate. But again, I don't really like annual here because it doesn't have to be annual. It can be quarterly. It can be monthly, depending on what is uh, the time unit you're using. If are we dealing with monthly data? Are we dealing with quarterly data? Are we dealing with annual data? If it is annual data, of course, the growth rate will be the compounded annual growth rate, right? Uh, but if it is quarterly, then it should be called CQGR. If it is monthly, CMGR, right? So it's not a fixed term, right? CAGR is not a fixed term. And then, so finally, the fourth variable will be n. Now, this is more complicated. So before we talk about how we do solve for n, let's do the exercise for r. Okay, so open this file. Just open this file. You downloaded this last time, and now we go to row 18. Okay, in the row 18, what do you see? You have, of course, a $10,000 principal. There's always, I need to, as a precaution, I always have to take a lozenge to soothe my throat. Um, so you have $10,000. You have you want to grow it to $30,000 in 5 years. Okay, so you have a pre-selected target future value, right? The question is, what should be the APR then, right? And then in this case, it's annual compounded. Next one will be quarterly compounding. So it's not a difficult thing. We just apply the formula that we, you just saw. All you need to do is FV over PV leads to 1 over t, right? And which is, I cannot, although I want to click it in, when the formula is above it, when the formula is hovering above it, you can't click it in. So I'll just type in C, manually type in C18 minus 1. There you go. It has to be 24.57. Now, we go to row 20 because 19 is about finding n. We haven't got to that point yet, so we'll do the rates first. But this time, n is 4. So that means, we need to make adjustment. So then, FV or P, P raised to 1 over, okay, I forgot to. And then it's 5 years, but quarterly compounding. So we know total number of compounding, actual number of compounding will be t times n. So that's C20 times B20, since I cannot put them in. It's minus 1. Okay. But then this will give you, if you do this, this will give you quarterly rate. Quarterly, see, that's quarterly rate. Think about it. By any common sense, if under annual compounding, if APR is 24%, 24.57, almost 25%, if it is quarterly, it will be slightly smaller number, maybe 23%, 22%, but it won't be like this. What this means, this is the no, we're not using gold seek. This will be what? Obviously not annual rate, but quarterly rate. But it's asking for, we need to answer accordingly. And the question is asking for APR, right? The label is saying APR. And if under that label, if you're giving quarterly rate, then you're lying. I mean, you're not answering the question. So then what do we need to do? This whole thing simply needs to be then multiplied by 4, which is, D20. Whole thing, because the whole thing is quarterly rate. Yeah, we'll come to 22.59. That looks more like it, right? So if it is quarterly compounded. But then again, I've been telling you this, the simpler the model, the better it is. The simpler the model, the better it is. Why? Because if something goes wrong, I mean, anything structurally simpler is easier to fix. If, systematically, if it is, I mean, systemically, if anything is, or structurally, anything is simpler, it's easier to identify. If something goes wrong, you can identify the source of the problem easily. And if the system is more complex, it's more difficult to identify the source of the problem. And after identifying the source of the problem, it will be easier to fix if structurally, if it is easier, right? So that's why I prefer, a simpler model. So if we do the same thing by the simpler model, I would, just adding 2 more columns. By adding just 2 more columns, right, we can take care of that. The same problem. This is the same problem, right? Adding 2 more columns, column of, R, column for N, right? So to find first, because it is 5 years, N will be T times N. We need this first, right?
5, 10, 15, 20.
Yeah. Yeah. There you go. And then now, it's just future value or present value raised to 1 over n. Now n is here, right? Which is f25. Don't need to make any adjustment because adjustment is already made outside the formula, right? Minus 1. You go. 5.65, which is then what? That is quarterly rate. Then if we turn it into APR, we simply multiply that by n. There you go. We get to the same result, right? So
That confused me.
which one?
So how did you turn R is the rate, and then we looked for the
R is the R is the periodic rate, so that is the quarterly rate,
okay,
right?
that makes sense.
But the original problem
It's asking for APR. So
wants APR. So
why
then
didn't
you
you
give it.
multiply by 4?
Yeah, I did.
Okay, and that gave you APR?
Of course.
D20, E25,
Yes.
and then D20. Okay, that makes sense. Thank you.
R times n, right?
Yeah.
So we got to the same result, right? But as I said, um, if the model is simpler, right? If the system is, structure, any structure, right? Systemically simpler structure is easy to fix, easy to build, easy to fix, right? It's like, think about it. Nowadays on the cell phone, on the mobile phones, the battery is already, battery is not detachable. In the old days, if the uh, battery is, a battery turns bad, easily discharges and, it doesn't charge well, uh, depletes, battery level depletes, very easily. All you need to do is just switch the battery, right? But now, by embedding battery in the phone, and you cannot simply switch the battery, something goes wrong with the battery, you can't fix it, right? So actually, uh, I prefer the old phones, that you can, easily, easily fix yourself. These days, you cannot fix those phones. Once the phone is bad, and it's only because of the battery, you have to either upgrade it to a newer phone or completely buy a new equipment. Of course, they have strategic, phone makers have strategically, right, moved on to this system so that they will sell more phones, right? But again, even if you knew how to fix it, right? Disassembling the phone, first of all, you can't easily do that, and it's going to be very difficult, right? So the simpler the model or the simpler the structure, the better it is. Okay, so this way we can nail, all problems about R. Next, then what if we don't know n? What if n is uh, the unknown? Now, before solving, okay, so then the problem is, if we start from, okay, of course we got to start from the base formula, right? Now, here's our problem. This n is the unknown. How do we isolate n? How do we isolate n? Because I've been telling you always, um, okay, first of all, because n is the padlock on the cage, right? I use that analogy. This is the cage, and this is the padlock on it. the padlock. So cage and padlock move together, right? You cannot separate them. So then, uh, how do we isolate? First, so we will have to isolate whatever we can, isolate, whatever we can, do to isolate the cage and, padlock together. So next, what we do next, what we do next is, of course, isolate whatever you can. By dividing both sides by p, we isolate only 1 plus r and a padlock on it. Next question. I've been telling you all this time. It never, this is always true. I mean, this is the, basic rule for solving any equation. We all know as long as you can identify z equals x times y structure, right, you can solve uh, any equation, because any equation, right, if x is your unknown, we all know that's going to be z divided by y. If y is the unknown, z divided by x, right? But in this case, can you identify that structure? Can you identify z equals x times y structure? Hmm? No, you
Yeah.
can't.
No?
Yeah? What do you mean, yeah? You can identify that structure?
I was thinking FVP equals one is one, and then one plus R is another one, and then N is the third one. So FVP is X, one plus R is Y, and then N is Z.
Oh, you're saying this is x and y and z?
Yeah, that's what I was thinking.
No, no, no. But it's not. Look, this is a product, right? It's a multiplicative function, multiplicative, right? Z equals x times y. Only then you can solve for x or z, because then it's z divided by y. But how can you? Is this a multiplicative function? This is not. It's a power function, right?
Yeah.
And then if it is a power function, divide. You cannot divide, anything, you cannot divide it like this. You can divide it like this only because it is a multiplicative function, right? So that's not what you can identify. What you see is actually, like z equals x to the y, right? Which is quite different. This is power function. This is multiplicative function. So you cannot divide z by y, because it's, how can you divide it? This is not multiplication, right? So uh, you're stuck here now for now. But uh, to be able to solve this, we need to use log. Okay, so now we got to talk about, before we talk about log, a few more things. I believe in the last class, as we were talking about the properties of, powers, properties of exponent. I only showed you a couple of examples, but look. First of all, uh, anything raised to zero, becomes one. Why? I mean, let's go through all of these, to understand. Some of them we already did. You memorized it, from probably middle school, without understanding why. You just memorized it because the teachers told you. Just memorize it. Anything raised to zero is one. Now, but if you think about it, uh, x suppose what makes x to 0? For example, you understand another rule is, if the base is the same, x, I probably talked about this, x to the a times x to the b, it's x to a plus b. And, by plugging in a couple of numbers, we can, if it is 2 squared times 2 cubed, we know it's going to be 2 to the, it's 4 times 8, right? So we know it's going to be 32. But 32 is what? 2 to the 5th, which is, 2 to the 5th plus, a 5, right? And another rule, then what about?
Professor.
Yeah.
It's isn't it supposed to be 2 plus 3, not 2 plus 5?
Yeah. I'm sorry. You're right. This is being. You're right. Yes. Who was that?
Oh,
Who
it's
said
me,
that?
Anna.
Who?
It's Anna.
Anna. Oh.
Yeah. Good morning.
Good morning, Anna. Okay, Anna. Okay. I was gonna give 0.5, but you are not a student in this class, so okay. Somebody missed out on that, 0.5 point bonus. Okay. The next thing is, if you have x to the a over x to the b, so same base, right? It's x to the a minus b. And also plug in a couple of numbers, and you can confirm that. You can let's see. So as an example, right? Try this, for example, 2 cubed, same base, right? 2 squared, eight over 4, which is 2 to the 1, right? So that's 2 to the 3rd minus 2, right? And by this already, this becomes 1, right? So that makes, that's proven, right? Another thing, but this alone, we all know negative power is the reciprocal, right? Pretty much, x to negative n is 1 over x. 1 over x to the n. So then think about it. Knowing that, let's go back to I didn't even start. So suppose we have, x to the n times x to the negative n. Well, what is that? We know, okay, same base. So it's, x to the n plus minus n. So it becomes, x to the n minus n. that will be x to the 0, right? X raised to the 0. And then think about it. What is x to the, another way of writing this? Another way of writing this is what? X to the n times 1 over x to the n. Isn't it right? That's another way of writing that. And then we know this will cancel out. If they cancel out, because it's the same thing, right? Then what does it become? Becomes 1, which is, and once they cancel out, first of all, which is, basically x to the 0, right? Because, x to the n times 1 over x to the n is, x to the n minus n, right? Therefore, that is the proof. I mean, or rather, verification of why anything raised to 0 is 1. Okay. Now, with that in mind, let's think about how we approach, how we should approach this problem. Again, now we are stuck. I mean, it looks like, there is no way we can go. So then we need to then, if we understand, these properties of exponents, then next we should also understand the properties, what logarithm is. Log, right? What is log? Or logarithm, right, is a way of, expressing a large number by the exponent of the base, right? So in other words, it's a way to express a large number in a condensed way. So there are three commonly used, three types of commonly used logs. Okay. First is common log, right? Second one is binary log, and third one is natural log. But first, let's common log. And the common log is the log using 10 as the base. So for example, we can express 100 as base 10 log of 100, which is, base 10 log of 10 squared. Okay. And then base 10 log of 10 squared can be rewritten as, yes, 2 times, it's eventually 2, base 10 log of 10. Okay. Now, what is base 10 log of 10? Think about it. If base 10 log of 10 is basically 10 itself.
The value is 1?
Yes, because, it's, log of 10 to base 10, or you can read it in either way, base 10 log of 10 or log of 10 to base 10. And this simply means, 10, right? 10 to itself, right? 10 to 1 is 10. So this is 1. In other words, this is the number, right? The exponent is the number that this log has. And when you express it this way, one benefit is you can bring that exponent to the front like a coefficient. Now, why is it important? It's important because think about it. You are turning, because it was 100, right? Originally 100. 100 is what? 10 squared, right? When you turn it into log, right? It becomes 2 times base 10 log of 10, right? So what do you see here? This is basically what's going on here. This is basically, z equals x times y structure, right? You can turn something into z equals x times y structure. In other words, you can turn something that was a power function into a multiplicative function, right? If you turn it into a multiplicative function, then you can easily solve for this, right? Now, since we are talking, so that's one big takeaway from log. But also let's think about other cases. We know 100 is then like that. What about 1,000? I mean, 1,000 this way will be 3, right? And then 10,000 will be 4, and so on. Even 1 million will be 6 because it's the exponent. But here, the examples that we used have been only the numbers that are powers of 10, like 100,000, 100,000, 1 million, 100 million, 1 billion, all just easily. They can be easily converted into 10 to something, right? So what if we have a number like 13.726? I mean, if we have a number like this, can we take base 10 log of this number? Yeah, yes, mathematically and theoretically it is possible, but we wouldn't know if this is x. We wouldn't know what this will be. I mean, the computers and calculators can calculate it, but it's not easy to visualize, right? It's not easy to visualize easily. I mean, for human brain, it's not easy to. Another log is, so in other words, there is a limitations to the choice of what kind of number we can take a common log of. I'm not saying we can't. It's just not easy to visualize what that will be. Second type of log is called the binary log, and the binary log has 2 as the base. So it's like numbers like 2, 4, 8, 16. It's easy. This one will be base 2 log of 2, so it's going to be 1. Base 2 log of 2 squared, 2, right? Base 2 log of 2 to the 4th, right? This will be, of course, 3, right? Binary logs, of course, you can take binary log of any number, mathematically it's not impossible to calculate. I mean, computers can easily calculate it. But without using the computer, we can't easily imagine what's going to be base to log of 13.726 or something like that, right? Now, so we tend to have limitations in the choice of the numbers we take, binary log of. Third type of log is called, natural log, and the natural log uses Euler's number E, which is called Euler's number. Natural log uses Euler's number as the base. And what's Euler's number? Euler was, like 17th century German mathematician and Swiss German mathematician, German Swiss or Swiss German. There are two Swiss German mathematicians that made a significant impact on the modern mathematics. Since Isaac Newton, right? Since Newton and French, they were the French mathematician Lagrange and Swiss German Euler and German Gauss. So these people lived around like 17th century. So they are not quite contemporaries, but compared to like living in the 21st century and living in the 17th century, you can obviously there's a big difference. Another mathematician's name was Gauss. But here's the thing. The names like Gauss and Euler it's a proper noun, so we need to follow their pronunciation, right? In French or German, some people tend to anglicize it all the time, so call it Euler's number. No, that's like a you call Einstein instead of calling him Einstein, you call him Einstein, right? Or Einstein. If you call Einstein Einstein, you anglicize his name. That's like not disrespecting his heritage, or either you are very ignorant or deliberately disrespecting his heritage. So in honor of their heritage, we call Euler's number or Gauss. I mean, nobody would call it Gauss. If you call it Gauss, as I said, it's either it shows your ignorance, either ignorance or disrespect for their heritage, deliberate disrespect for their heritage. So Euler discovered this number, so it's called Euler's number. We have to understand Euler's number. We just to understand natural law. So and to tell you what natural, we are out of time, so we're out of time. We're gonna have to do this on Monday. So I should call it a day. So that's it for today. Any questions so far? Any questions? Any questions? Okay. If you don't have any other questions, so have a great day, everyone. And I will see you next Tuesday. All right. Okay. Class dismissed. So I'll stop.